Okay, now we're ready to talk about binary numbers. Binary is just a fancy name for base 2. Base 2. It's a very crazy numbering system. There's only 2 digits. The 2 digits are 0 and 1. And what do we have? It's a positional system. There's various places. There's the ones place. And then there's the twos place. It's base 2. You multiply by 2, you get 2. You multiply by 2 again. 2 times 2 is 4. Multiply by 2, 8. By 2, 16. By 2, 32. By 2, 64. So it's a little bit tedious. You end up with very, very long numbers. For example, if you had, and you can't, the only digits you have are ones and zeros. So if you had 1 0 1 1 0 1 0, that is 164 plus no 32s plus 116 plus, well, we know what happens when you multiply a number by 1. We know what happens when you multiply a number by 8. It's plus an 8 plus no 4s plus a 2, which is what? 64 plus 16 plus 8 plus 2. You can just see it across. 164, a 16, an 8, and a 2, which is 64 and 16 is 80, 90. So we would say that 10111010 in base 2 is the same thing as 90 in base 10. If you want to go backward, and say something like, how do you convert the number 75 from base 10 is what in base 2? We'd say, let's see, we can fit a 64. We have 164, so 75 minus a 64 is 11. We now have to make an 11 with the remaining places. There's not enough to subtract us to 32, so we have no 32s. We don't have enough for a 16. We have no 16. We do have enough for an 8. We can put one 8 in there, and we'll have 3 left. Not enough for a 4. There's 1 2. And there's 1 1. And therefore, 75 in base 10 is equal to 1001011. Now this is very, very tedious. What we can do with 2 digits in base 10 requires, what is that? 7 digits in base 2. Why on earth would anyone want to work in base 2? Well, deep inside of a computer is just a huge number of on-off switches. And once upon a time, there were actual physical little switches. You could, like an abacus is a sort of a calculator. You slip things up and down. You could convey information with a whole wall of light switches, the patterns of switches being up and down. You could communicate things. But the cool breakthrough with computers was when you were able to get switches that didn't have moving parts. You would send a little pulse of electricity and a gate would be open. You'd send a pulse of electricity, a gate would be closed. On and off, little tiny switches. And, oh my goodness, when you talk about an iPhone having 16 gigabytes? Is that right? A megabyte is 1,000,000 of those little switches. A gigabyte is 1,000,000,000 of those switches. So an iPhone with 16 gigabyte is 16 billion little on-off switches. And they all represent ones and zeros. And with ones and zeros, you can represent numbers. And with numbers, you can have a picture. What's a picture? Every single picture is a number saying what color and how bright that particular pixel is. This is why pictures take up huge amounts of memory, because every single picture has a number. But with a whole string of numbers, you can depict a picture, and with nothing but ones and zeros, you can represent a whole string of numbers. And if you've got 16 billion of them, you can do all sorts of cool stuff. You can have music reduced to numbers. That's called digital music. The digits, the music has been turned into nothing but digits. This is why on computers, it's sort of a cutesy thing. when you have an on-off switch, let's see if I can draw an on-off switch. You have the switch that looks like this, and there's like a 0 on one side and a 1 on the other. So this is on, and then you snap it, and it goes the other way. This is on. Oh, isn't that cute? See, 1 is on, 0 is off. Sometimes you just have a button that goes like this, and there's, I believe, this symbol on it. That's a 1 and a 0 superimposed over each other. It's the same button. You push it once, and it goes from 0 off to 1 on. You push it again, it goes from 1 on to 0 off. Ha ha ha! This is nerd humor. Anyway, binary numbers are how you, at the very, very heart of a computer, someone has to be writing in ones and zeros to communicate to a computer. Now, fortunately, we have interfaces that you can use a mouse, you can click on things, and what we are doing is we are interacting with software, and that software interacts with other software, which interacts with other software, which at some point has to turn everything into ones and zeros for a computer to understand. But this is why base 2 binary numbers are at times rather interesting.